All right, well, thank you for coming to this talk. For some quick context, raise your hands if you're not familiar with module federation or know what it is. Okay, wow, I'm impressed by the amount of people who didn't raise their hands. Okay, it's actually getting popular now. Okay. All right, so for those who don't know, the general idea behind federation was when you work on a front-end code base, generally you're working with a monolith. And if anybody's worked with a monolith, at some point it stops working. Usually how you try to break the problem up is something like an NPM package or maybe a monorepo. If you want kind of independent delivery, you're probably leaning toward NPM package publishing. The big challenge that always comes with this, though, is it's really hard to scale. And you kind of get into this like double deploy hell where you want to update button, you have to release it, you have to turn around, install button into header, release header, turn around and install header into your application, and you're finally there. So there's a lot of friction in the flow. So anyway, I tried to set out to solve that. And so my solution to it was federation. The main goals of it were, something that offers autonomy, minimal UX drawbacks, and something that's relatively simple to work with. And something that can ideally try to recycle code. I think big thing in micro front ends, maybe before 2019, this was a really big challenge. You could do it, but it was kind of like the butt of every joke, micro front ends, because it was super wasteful, very inefficient. So a big thing I really wanted to do was to be able to actually share dependencies and share code and recycle what's already available that will work. And so federation came along. Federation doesn't just work in the browser. I have seen it in game consoles. I have seen it in cars. I have seen it in drones, Electron apps. Pretty much everywhere I've seen it run. Obviously, server-side node, it works as well. So it's really nice that you actually have a solution for distributing and consuming code that works anywhere that JavaScript is capable of executing. And it's been about 4 years since Federation was released. And in that time, we've gotten a decent user base. We'll see a general trend that showed up, which is kind of what it was designed for. And that was leaning toward the larger companies where the problem of scale, really starts to implode and there's not much choice to fix it. So, what I found quite interesting was 30% of Fortune 50 companies are powered by Federation. So I've always been really impressed by that. And, we've got, almost 500,000 companies or sites that we're tracking that currently implement the technology. So it's grown. But it's also time for redesign. So when it was originally designed, what I kind of wanted was code splitting between different builds. That was the general idea, or that's what I thought we needed at the time. But a couple years in and lots of user feedback, many workarounds and hacks, we started to realize, and also just 4 years into it, architecture has changed, the demand has changed, how we're building these applications has grown more complicated. And what Federation was originally built to do still does it fine, but it's not necessarily strong enough to the end user to enable your really complicated scenarios. So what I thought I needed was dynamic import between bundles, and kind of what I actually wanted or needed is express middleware on your import chain. And so anyway, so we kind of, and also, new bundlers are coming into the picture now. Webpack is still a great API, but, it's losing a little favor because of speed concerns and probably one of the biggest things that kind of weighed Federation down was this kind of concept of the lock-in to a bundler. So, we wanted to try and address that. So let's rewind 12 months. So 12 months ago, I was on stage at City.js. And I had maybe a week before, I came across this new compiler that was just out. And it was called RSPack. And what was really neat about RSPack, because I'm a big Webpack enthusiast and loyalist, probably defended it for a lot longer than a lot of others have when it started to fall out of favor. But I really couldn't find something that could replace the strength of Webpack's API. So for me, it was always worth the trade-off. I always think of a bundler as kind of like a workhorse. I don't need it to go quickly, but that's nice, but I really, really need it to be strong. So anyway, RSPack kind of came out, and the whole idea with RSPack is it's Webpack written in Rust. Everything works, So that was really cool. And this is, again, 12 months ago. This thing just showed up on the radar, and I kind of announced it, or the first kind of speaking about it was here at CityJS on stage. And actually, after that conference talk, I got a message from the team that built it saying, hey, do you want to come work here? So guess where I work now? So let's go back 9 months. I start working at this company, and I find out that it's a ByteDance, by the way. And I found out that ByteDance is actually the largest user of Federation that I have ever seen or heard of. So another great win. And what we ended up seeing is a lot of investment into the technology. So what we ended up doing is unifying our internal infrastructure team and our resources into the Federation layer. And this has been really great. And that was about 9 months ago where we announced we're going to start doing that. 4 months ago, the crab gets the gauntlet. So Federation rolls into RSPack, and it's got pretty much all the support that you would expect from Federation. But when we did that, like I said, still need a bit of a redesign here. So there's a couple extra things that it comes with now. So the big thing that I really, really love is look at the speed differences there. So on the one side, we have an RSPack build, and on the other side, we have a Webpack build. They use pretty much the same Webpack style configuration, all the same loaders, but the speed difference is pretty dramatic. We're seeing average builds there of around 200 milliseconds, but on the Webpack end, you're seeing 2 to 4 seconds in your build. And this is generally what you would see. So if you do use Webpack or something like that, it's mostly a drop-in replacement if you did want to switch. And the general rule of thumb we expect to always see is a straight 10 times improvement on compile speed. If your build takes 40 minutes, it'll take 4 minutes. Easy math. So let's see. All right, so then we came out with something called Module Federation Enhanced. The idea behind it was a major rewrite, introduce hooks and an SDK, and again, with RSPack's introduction, we needed an effective way to decouple it from Webpack. To do the decouple, though, I was also trying to think about more bundlers, the future of this, and not kind of repeat the design that I had implemented into Webpack. So with how we redesigned Federation, we kind of ensured that it operated more like single spot would. It's a runtime library that the bundlers can implement. And this is really great because it means that I can centrally maintain Federation in the Rust side and in the Webpack side and in any other bundler that we pull it into, and I don't need to recompile, say, RSPack in order to upgrade, change, or continue to modify Federation. All right, so the first thing we added was this runtime API. So this is kind of the nice thing about it. If you don't even need the Webpack or RSPack Federation plugin to utilize Module Federation anymore, since all they do is pass some data from their build into the runtime and initialize my runtime. You can also just use the runtime. So this is quite nice because before there were a lot of hacks on how you could, like, say, dynamically load a remote. Sometimes you statically define them, but what if you don't know what you're defining, or user configs influence it, or white labeling, A/B testing, all of these things? It became really tricky to dynamically load them. And so pretty much we've introduced, the same style of configuration that you would get from our runtime layer. We also have this, the same kind of thing if you want to share code. So consuming code, sharing code, looks very similar to how the plugin operates. And you can, use load share to centrally resolve React and not, pull it in multiple times. So same mechanism, but you don't necessarily have to be hooked to a bundler to do it. Then this is probably the best piece that we've rolled out so far, and that's this concept of runtime plugins. So Federation really gives us the ability to import code from any other bundle and only import what we don't already have. This sounds really great in theory until you spend a couple of years scaling it up, and then you realize there's a lot of challenges. you need some kind of life cycle to control it. Similar to how React has a life cycle, dependency loading, you kind of want some life cycle on it. What if a remote isn't online? What if there's a weirdness with package resolution and you want to share code, but you have one problematic code base that can't just utilize a single instance of it or needs an older version that might break the rules of the rest of the system. Tons of things where you kind of want that middleware life cycle, where within context of what's happening between the provider or the consumer, you want to control that relationship. And that's where the runtime plugins come into play. The big thing we introduced was this idea of a four-way handshake. So the idea here is, in the first version of Federation, the thing being consumed has no control over how it's consumed. And this is quite problematic because you couldn't say reject being consumed or put auth around your module loading or A/B test it. Anything you had to do it in the consumer end. And that kind of breaks the rules of micro front end, where if I have to go here and tell it how to consume it, then what's the point in providing it? So the four-way handshake means that this life cycle will run in your host or the one consuming it, but the same life cycle will also run in the remote. So the remote knows where it is. Who is busy calling my import? Who is asking for something from me? Are they allowed to consume me? All of these type of things, and you can choose to reject being consumed. And because of the context layer there, similar to like React context, you could say, well, I'm going to import header everywhere, and that's just a static import. But depending on who's importing header, I can change what's being imported. Or depending on the region that this is being loaded, you can again change what your import actually means. And you can do this, relationally, you can do it globally. There's many ways that you can kind of take advantage of these life cycles. And we have many more on the way, but generally, this is a good spread of what to expect. So some examples of how to use this, which is really nice, is, in this example, I'm going to switch out Lodash. And I'm going to now change React DOM, and I'm going to tell it actually override the rules, and I want to use React 16. So app 1 is now using 16, which is originally vended from app 2. And even though my demo is a little messed up because it should show the used ends there, but clearly my code is not great. But you can see on some of them, I can actually see which applications are depending on these versions and what they're currently using or what the overrides are and things like that. And this is all just from in-memory within the Federation layer itself. We also have, offline remote, which has been a major problem. I've heard about this issue for years. If the container or the little layer that you connect to cannot be reached, it's very hard to catch it. You could maybe sometimes use like a dynamic import, but the dynamic import won't work if, say, the whole container isn't available. It'll cause like a hard crash inside a Webpack. So it wasn't necessarily completely resilient. And if you use import from, then it's game over if something goes wrong. So using the new runtime API, we can write a little runtime plugin that can handle offline remotes. So I have two apps here, and one of them is not online. And instead of it crashing, it just tells me, hey, couldn't get it, and that's the reason. So what would the runtime plugin look like for that? That's pretty much it. Error load remote, get whatever you want, which you can see in my error message is just a little like JSX-y message that just pulls the data out of the plugin. And you could have this thing do a dynamic import and load another component if you're offline, fall back to NPM, or you can just refire the whole life cycle and say, hey, well, you errored, so now the offline remote is origin number 2, and rerun the life cycle. And if origin 2 is offline, it'll just loop until it finds a success or until you bail out of it. So another nice one is the concept of API-controlled remote configs. So a lot of people have wanted this dynamic control or ways to kind of change this based on what's happening. And this is a very rudimentary one, but essentially I click the button and it's swapping a new container in there. And I don't have to have these all hard-coded, and I don't have the logic written to say, oh, well, when I click this, import from app 3. It's just import app 2 button, and every time I click it, the kind of middleware layer of Federation is swapping the dependency layers out for you. So basically what that means is import from some string has no real, recollection or no real importance. And this is kind of what that custom plugin looks like to write. I'm using local storage right now and I have an override map or whatever, very basic, but that's essentially what it does. And this is what it would look like to implement. Normal federation config, URLs that don't go anywhere, and I've got my runtime plugin that I kind of set. And again, import maps, can rewire them to where they go. You don't need to know them up front. You can put whatever there, and you can kind of rebind them as you want. So some new features we've brought in as well. Big request has been TypeScript support. And we finally have it. That's the remote. That's the consumer, and there are the types, and it's already there. So you've got hot reloadable distributed TypeScript definitions. This works with third parties. This works all the way down the nested chain. And if you just use the Federation enhanced package, it just works out the box. Nothing to configure. Maybe one thing you add to your TS config. We also finally have fast refresh and real hot module reloading. So I did this yesterday just to make sure it works, but type whatever you want in there, and you'll notice this is not live reload, but it's actually real fast refresh. And these are, again, multiple apps. It'll work nested, typically how a normal monolith would work, same experience now. So I'm very thrilled to have this one working. We have also introduced the concept of runtime lock files. So lock files are a big one. Federation is not very deterministic. If you ask for React, you will get a React in that version. But you can't specify, I want React from over here. So caching is a little bit tricky to deal with and so on. But you can see we support API endpoints or JSONs that you can use instead of the JS file. From there, we can do a whole bunch of stuff. But essentially, I can now point this to an API or something like that, and I can pull back a manifest that instructs it what to do. In this case, our edge worker looks something like that. We pull our manifests for production, and we can calculate what Federation is going to do with the generate snapshot from manifest. So our production environments are that calculation. If we change the database value, production changes. And it never deviates from whatever that lock file says. Always works the same way every time. And that's how you would implement that manifest. Use a runtime helper in the runtime plugin, and we just bind it to a snapshot. And we have something in the layer that knows how to look at it. We have also got Chrome DevTools now. So seeing what's going on isn't a nightmare. You can override them with the module proxy, which is great. Using those manifest URLs, you can see who's using what and where, what they vend, all of that. And you can also, when you populate those, you can hot reload these in any environment. So if you're in production and you want to debug a staging header, Chrome extension swaps it out wherever you want. We also put out new docs. It's been a busy year. The new docs are still a work in progress, but if you want to find out what's going on, this is where you can kind of go to find it. And another big one I think we've all seen is the deploying and management of these things probably gets a little tricky, especially as you start to scale it up. And it was definitely hard, or it was hard. But inside of ByteDance, we have something called VMock. And the scale of how we use Federation at ByteDance is quite significant. Thousands of deploys a day, tens of thousands of engineers, tens of thousands of repos, and I think every remote has thousands of versions on it. So distributing this everywhere and managing it at a tremendous scale can get quite tricky. But unfortunately, it's an internal tool only. And we really need this for, be nice if it was solved. But after looking, and this is what our VMock looks like internally. So that's how we kind of manage all these things. But it'd be real great if there was something that others could actually use. So I was definitely inspired by what we have internally. And so we decided to take a project that I had called Medusa and give it a rework. So this is what Zephyr looks like. We've got our little side panel in here. These are all the individual remotes or containers that we've got. This is, the typical tractor one. You can see the remotes that we're pinning for which version and so on. And the nice thing about Zephyr here is you don't need any Git, you don't need any CI. If you build it locally, it is already deployed. The only thing stopping you from using that code in production is any artificial limits you choose to impose. But from a delivery and distribution standpoint, Most compiles are ready to be consumed in real user traffic in under 10 seconds. Setting up Zephyr in a existing app or something like that, Jack Harrington has a Create MF app, CLI, which is quite nice, so we tried that out, and it takes less than 60 seconds to go from new repo to looking at it in production, and you've torn down your local instance and it's already available. What's really interesting here is you can see we've got tags, obviously, and build versions. We record every build version that's available. The nice thing about Zephyr as well is it is bring your own cloud. So we don't mark up any hosting costs because we don't want to host your stuff. We just want to manage your hosting. So if you use AWS, Netlify, Cloudflare, whatever your provider is, it all stays in your VPC. Kind of like Kubernetes for the front end. And the nice thing as well, it also hot reloads. Anytime you change a version, the environment will change and it will show up. What's really interesting is we've seen, when we were developing on this, we have someone working on the header remote, somebody working on the page remote, and whenever one of us makes the change, it's all unified, and we're seeing everybody from around the world who's working on this, and the updates are coming in live on the spot into it. So you can actually have multiple people work on the same project, and you don't need to push and pull and synchronize things back and forth the whole time. It also has visualizations, which are nice, and things like that. Let's see, so a very basic example here. Again, I've got hello world, I open up my side panel, and I choose that, and hello city.js, and that's effectively it. If I push publish update, that's my deployment. And that's really it. That's what our production deploy looks like if you wanted it to. We also have unmanaged remotes. So even if you're not using Zephyr, you can use its intelligence engine sort of to control and manage all of this stuff. And if you do want to check it out or sign up for it, it's in Alpha 1 at the moment, but Zephyr Cloud IO, or you can grab the QR code for it. All right, I know I don't have much time left, so just a little bit more. So if you do want to see that Create MF app one, which is like 60 seconds and you're in prod, there it is, and the instructions for it, pretty easy to kind of get up and going. All right, so last little bit here. Federation's great, but the family has grown a little bit. And this is what the family looks like now on our infrastructure team. And you'll see a lot of crab guys here. These are all variants or products built on top of RSPack. We also have OXC, which is our kind of like SWC, but it's extremely fast. So fast that if you use OXC lint, you can lint your entire file system in, I think it was 4 seconds. So it's pretty quick, millions of files. We also have modern.js and a couple others, but I'll quickly get into them. So we have RSPack, which is just Webpack written in Rust. What's quite nice about RSPack is, generally it's drop-in. Currently, we are 76% of Webpack's API. All their ecosystem tests pass, and that's where we're sitting. I believe by June or July, we will hit the 90 percentile or the V1 range, and we'll kind of start going beyond just catching up. I have this in twice for some reason. All right, so speed-wise, like I said, it's significantly faster. You're looking at 10 times the speed. That's generally what you should see. We also have our modern.js solution here, which again, if you're looking for like a framework that's really friendly to micro frontends, this is essentially like Remix, but for micro frontends, and it uses a lot of the Remix stuff under the hood as well. So it's not another framework that you have to deal with. We have RS Doctor, which is pretty nice. So bundle analysis is hard, and there's not been much change in the space for a while, but finally there is. So actually being able to see why things are the way they are, being able to see where your file sizes are coming from, who's using what, being able to actually diff it and see the code that's loading in here and how tree shaking is used or unused to actually know, are you tree shaking correctly? What's not getting shaken out? Actually seeing why things get slow. You can now see how long each plugin takes. You can see how long each loader takes, the resolve time for each loader, for each file. You can even see the diffs between them. When it does the resolver, what did it resolve and why? And you can also see the loader chain to know exactly where all of your speed has gone. And this works for Webpack or RSPack, which is quite nice. We also have RSPress, which is what all of our docs are based on, basically static site generation style, but built on the Rust toolchain with a lot of things built in, so you don't really have to look around for cobbling together solutions. And oops, and yeah, modern's already in there. So a little bit on our roadmap. So we've already got some of this family in here. We are working on something called RSlib. Pretty much what we've done is we've partnered up with Webpack, since we have a lot of things in common. And we're working, I think, at the Google Summer of Code I think it's in Norway. But we've come together to decide what do we want to improve, because we don't just want to improve RSPack and kind of not really pay our dues. So we collaborate quite a bit with them. One of the big things that we're working on with them is import map support. So actually getting a Webpack build, RSPack build that can do import maps. RSlib is going to pretty much be RSPack-driven solution for package building. If you've ever built Webpack and you try to use NPM, like build an NPM package, you lose your tree shaking, or it doesn't work well with CSS. There's a bunch of other problems. So we're going to try and solve that so everything works kind of the way that you want. And we're taking a little bit out of TurboPack here with their multiple output targets, or parcel, and we want to make it so one build can output RSC, CommonJS, ESM, browser, service worker, and you don't need like 4 compiles to do it. In modern JS, we're going to be bringing in Node and SSR support, and we will have 2 major OSS things getting added, but I can't really speak about them just yet, but stay tuned. So anyway, really high level, really quick, but thank you for joining this, and if you do have any questions and you can't catch me now, I'll be around and I'm happy to chat.